Hi students, welcome to our physics class. In this class I am going to continue the topic electricity, the subtopic about conductivity. What is conductivity? Conductor which allows current flow through that object which allows current flow through them are called conductors. Now here conductivity, that is a nature of the conductor is conductivity, that is opposite to the resistivity. In previous class we discussed about the resistivity. What is the resistivity? Resistance means obstruction of the material, resistance of the substance per unit area and unit length is called resistivity. For resistivity opposite is conductivity. So resistance is obstructor, conductivity allows flows current. So both are opposite. So here conductivity is symbol defined with sigma. Conductivity is opposite to the resistivity. Conductivity is opposite to the resistivity. So sigma equal to 1 by rho or 1 by small p. This is symbol of resistivity. Sigma equal to 1 by rho, or this is inverse. Both are inverse. So here conductivity is equal to 1 by rho. Now conductivity sigma equal to 1 by, resistivity formula Ra by L. This is resistivity Ra by L. R means resistance, A means area of the conductor or thickness of the conductor or cross section, anything you can take. Area, resistance, area by length of the wire. In previous class we discussed resistivity Ra by L 1. Now 1 by Ra by L. If you simplify this, you get L by Ra. L by Ra, that gives conductivity. Formula of conductivity is L by Ra. So length of the wire by resistance into its area of the cross section. Now units for conductivity. From this formula only you can write length meter, resistance ohms, area meter square. Now here meter, square meter cancels. Square and meter will cancel. Here meter square now. Square and meter will cancel. What meter remains? So what remains here? Finally 1 by ohm into meter. Ohm into meter. Ohm is symbol of, ohm is unit of resistance and meter is length. Units of length. Now 1 by ohm meter. Also we can write ohm minus power 1 m minus power 1. If you bring numerator, you can write as minus power 1 for both. So this is the unit of conductivity. Conductivity is inverse to resistivity. So from that we got it. Now next, selection of wires. This is last concept in this unit, in this lesson. Selection of wires. Which type of wires you are going to select when you are dealing with the electricity? First one, less resistance. Yeah, conductor with less resistance. Helpful. Less resistance will not give heat. Will flow current without obstruction. So the wires which have less resistance are good conductors. Example, aluminium, copper, silver, these are. You know that silver is very less resistance than all other metals. Silver is very less resistance, but we cannot use. Why? It's very costly. Costly thing cannot purchase. Difficult to purchase wires, for wires, silver. So that is why we don't use silver. So better than that, we can use another one. If we compare with cost, so cheap cost aluminium, copper, these are available for us with cheap cost. So that is why we can use for conductors with less resistance. Of course, silver is very less resistance, but difficult to purchase. Okay, next, not affected by heat. Yeah, wires should not be affected by temperature of the surroundings. So that should not be affected. So such type of wires you should select. For example, street wires, we see current wires in the street poles. So should not affect by the, not much affect by the temperature of the atmosphere. If it is affected, obstruction will take place. So not affected. So heat should not affect by the, heat is not affected to the wires. Such type of wires we should select. Next, fuse. If you take fuse, that should be low melting point. Thin wire. Fuse should be thin wire and must have low melting point. Why? If anything wrong connection happen in the house or any connection, what will happen? Heat generates. Heat generates in the circuit. Immediately the fuse must stop the current flow from the beginning, from the main. Fuse helps to stop the current there itself. So that should be, so that is why fuse must have thin and low melting point. That means what? For any small heat only, that should cut first. The fuse must cut itself, there itself. Put off current flow there itself. Will not allow to throw out house. Otherwise, what will happen? Due to heat, the total house will burn. House circuit will burn. So that is why fuse must have thin wire and also low melting point. For small heat only, it should cut first itself. Then current supply stops there itself. So thin wire and low melting point. Next, filament. Filament, bulb, filament continuously burning. Because of heat only, the filament is burning. Why heat will, high resistance. Filament have high resistance. So due to heavy collision, it generates more heat energy. Collision between electrons and positive particles. Positive particles, electrons collide more and more. Heat generate huge amount of heat. That is why burning. Filament burns, give light. So that should be high resistance, resting power. That is why must high resistivity and also when heated should not melt. High melting point. High melting point, high resistivity. Then only filament should burn and will not melt. High melting point. So like example, tungsten will not melt but easily high resistivity, easily burns, will not melt. Both. So tungsten used for high resistivity and high melting point for filament. Next, heaters. We use nichrome wire. Why we are using nichrome? High resistivity. Get heat. Heaters, we need heat. Oven, geyser, iron box, heaters. We need heat. We should generate the heat. So that is why high resistance, high resistance conductor we must use nichrome. When we connect to the current, immediately resistance is high and produce high heat, heavy heat, and that heat is helpful for us in different ways. Heaters, heaters, and oven, and iron box, and heat generally geyser. These all we need heat. So nichrome in heaters. Next, nichrome wire. Next, superconductors. Some examples, some lead, tin, superconductors. But superconductors difficult to get in a normal temperature. Superconductors are good conductors in low temperature only, not in a high temperature. Superconductors are good conductors, means less resistance. Resistance is very less when the temperature is very low. Example, tin and lead. They are good conductors, but for small temperature only they spoil. So should not be heat. And low temperature, room temperature, below room temperature, they are good conductors. Tin, lead. That is why they are connected to computers. Inside the computer, lead and tin are used for conductive, small thin wires used in computers. But temperature should not increase. If the temperature increases, they spoil. So that is why we should maintain the computer's device, self device in low temperature. So they are good conductors with the low temperature. They are called superconductors. Superconductors are zero resistance. Resistance is nothing, only conductivity, no resistance. When low temperature, such a way we can select different wires for different purposes and different uses. Thank you. That's all for now. We'll discuss remaining next class.